So I will be discussing this problem C of today's weekly contest, lead code contest. So maximum, which is maximum score after applying operations on a tree. Okay. So here you are given a tree and you note what tree is. So it will be having n nodes and n minus one edges, and edges ai is represented by ai bi, means representing that there is an edge between nodes ai and bi in the tree. Okay. So now you are also given a zero index integer array values of length n, so which basically denotes that what is the value associated with the ith node. Okay. So you have to perform some operations and you start with a score of 0. In one operation, what you do is that pick any node I. Okay. So you just pick a node I, then then add the value at that node that is given in values I to your score. Okay. Means now the score would become score is equals to values I plus score. Okay. And then after you have added the value to your score, you will set the values at that node to 0. So now what we have to do is that a tree is healthy if the sum of the values on the path from the root to any leaf node is different than 0. Means you have to tell and return the maximum score you can obtain after performing these operations on the tree any number of times so that it remains healthy. So let me explain what you have to do. So you have to just find the maximum score you can obtain, ensuring that the tree is healthy. And when the tree is healthy when every leaf node, suppose this is the root node and there are some leaf node, every path from the root to leaf node, the sum of the values in the path from root to any leaf node is having value greater than 0. So if this is holding true, then that our tree is healthy. Okay. So let us discuss the example, then you will be more clear. So here here the value is 5. Then at you can see this. So at node 1 value is 2, then 2 5 3 2 1 and 1. So according to the means explanation, what we have chosen nodes. Let me pick another color. Okay. So if we have, okay, so if we have chosen 1 2 3 4 1 2 3 4 5. So means I have left this node. So you can see here that I have left the root node itself. So obviously every path from this root to a leaf node will be having greater than 0, some greater than 0. Why? Because obviously I have set this value to 0. All the nodes which I have selected, I will set the values to 0, and the node which I have not selected, that is the node 0, will be having value 5 remaining. Okay. So you can see that all the path 0 to 1, then 0 to 5, and then 0 to 3, all is having value 5. All is having value 5, that is greater than 0. So our condition is holding, and the maximum score you can get in this. What was the summation of all these nodes which I have selected? I have selected 1 2 3 4 and 5. So sum of the values of the path from the root to any leaf node. So 1 2 3 4 and 5. So 1 2 3 4 and 5, you can see it is 11. So this is the maximum possible score. I hope the question is clear to you. So let's also see the second example. Here the values are 20, then 10, then 9, then 7, 9, 7, 4, 3, and 5. And according to the explanation, which nodes we have selected? Which nodes we have selected? Which nodes we have selected? We have selected nodes 0, 2, 3, and 4. 0, 2, 3, sorry, 3 and 4 means all these nodes will be, we can say, so summation would be 9 plus 20 plus 7 plus 4. So you can see here the answer is 40. And how, let's check whether the tree is healthy or not after this selection. So which nodes we have not selected? Which nodes we have not selected? First of all, the nodes we have selected would be having value 0. Okay, so I will set these values to 0. And let's check whether the sum of nodes, some of the values at nodes from the root to any leaf node is greater than 0 or not. So if I just consider this node, so 0, 0, and 5, so it is having value 5. 0, 0, and 3, it is having value 3. Then 0, 10, 0, it is having value 10. And 0, 10, 0, it is again having value 10. So you can see that it is all the leaf nodes, that is 6, 5, 3, and 4 is having value greater than 0. So I can say the my tree is healthy, and this is the maximum score I can get, ensuring that my tree will be healthy after the selection of the nodes. So how to solve this problem? Also, let's have a look over the constraint. So number of nodes can be 2 into 10 to the power 4, and ages, number of ages can be n minus 1. Obviously it is a tree, that's why. And values can be 10 to the power 9. So let's move toward the solution part. So before moving into the solution, approach of the solution, I am going to explain a technique first of all, which you should know while solving a tree problem. So suppose your tree is like this. Okay, and you perform DFS, and you keep on pushing all the nodes you are visiting in a vector. Okay, so you have started DFS from here, so you have pushed 1, then 2, okay, then 4, okay, then 5, okay, then 3, then 6, and 7. This is what will be the order of the DFS we will get. So one thing you should observe, suppose if I just ask you which are the nodes which lie in the subtree of 1, can you answer from this array? Obviously yes. If you know that the number of nodes in this subtree is, what is the number of nodes in the subtree, that is 7, it is 1, 1, 1, 1, 3, 3, and 7. So I can say that starting from 1, all the nodes, 7 nodes, would be lie in the subtree of 1. Obviously I can say. So this is the observation. Similarly, this will hold true for all the nodes. You can see if I ask for the second node, then second nodes start from here, and I know that it is having size 3. Okay, so 2, 4, and 5, you can see 2, 4, and 5 is lying in the same subtree. Means what I am saying is that the the nodes in the subtree will be continuous in DFS traversal. Hope I traversal. Hope you have got this concept. Means you can see also for 4, you know that it is a leaf node, so it is having size 1. So you can see only this is the subtree of this 4 node 4. Suppose similarly, if you see for the node 3, then 3, 6, and 7, because it's having size 3, so 3, 6, and 7. So I hope this concept is clear. And let me just tell you about the solution. So the solution of this problem will be dp plus dfs, and the concept which I have told, I have solved using this concept. Okay, using this approach. So first of all, why dp? Why dp? Because because you don't know leaving which nodes, leaving which leaving nodes means the node which I have not chosen for my score, and obviously the its value would not be added to my score variable. Okay, because you are not sure leaving which nodes will be optimal, will be optimal. So you will have to try for every node. So every node which I mean is that, suppose I just explain this. Okay, 0, then 2, then 1, then 6. You will see here, I will ensure that the tree is healthy, but there are again there will be many possibilities to ensure that the tree will be healthy, but we have to find where we can get maximum score. So it was having value 20, then 10, then 9, 2, then at 3 it is 9. Oh, sorry, it is 7, it is 4, it is 3 and 5. Okay, so what I can do, one possibility is that I will just leave this first node, root node. Obviously, this will satisfy that the tree is healthy, because if I leave this, so all other nodes will be having value 0, but it will be having 20. So obviously, all the paths from the root to any leaf node will be having value will be 20, that is greater than 0. But in that case, what would be the score? What would be the score? Let's just compute. 9 plus 10. This node will be left. This node will be left. This will be left. Means these all these nodes will be included in our score. 5 plus 3 plus 7 plus 4. Okay. So what is the score? 19 plus 5, 24, 27, 27 and 7. 27 and 7, 34, 34 and 38. And you can see what is the maximum score. It is 40. So obviously there exists some other possibilities of doing of ensuring that the trees will be healthy. Okay, so that's why I have chosen DP. So I will have to try all the possibilities of ensuring that the tree will be healthy, and will choose which will be giving us maximum score. So what is the optimal way here? What is the optimal way here? I have also set this value to 0, means I have included this node in my score. Then I have included 2, 3 and 4. So what will be the, means I have left these nodes 1, 6 and 5. So what would be the obviously these all values will become 0 because I have included them to my score. So you can see the tree is again healthy, again is healthy, because for this leaf node the score would be 10. The sum of the paths of the values of the nodes would be 10. For this it will be 10, it will be 3, it will be 5. So you can see all the leaf nodes are having value greater than 0, so it will be healthy. And in this case I am getting the maximum score 40. How? I have included 20 to my score, then I have included 9, then I have included 7, and then I have included, what was the value, what was the value here, 4. So 20 it is here, and 20, 20, 40. So that's why I have chosen DP, because I am not sure going for which uh, means leaving which nodes would be optimal. Okay, leaving which nodes will be optimal. So I will have to try for every possibilities of ensuring that the tree is healthy. And now, why DFS? DFS, why DFS? Because I know, you know, that for computing this order which I have explained, that for a tree, for computing this order, you will require DFS, because obviously what I have done here is just simply run the DFS. And also, one thing you should have observed that I have also talked about the subtree size. So obviously the subtree size will also be computed using uh, DFS. So for computing the subtree size, subtree size, and then order vector, order vector, or what we can say, order vector. And also I have used this DFS for marking leaf. Sorry, I have not used for this. So order vector, that's all about the solution. And let's actually dry run over the, so dry run over the solution. So I am going to discuss this example itself. So suppose, so what would be the, first of all, I would be computing, first of all I would be computing the order vector. Suppose I am having the order vector and subtree size available with me. So what would be the order vector for this example itself? So order would be 0 first of all, then it would be 2, then 6, and then 5, then 1, 3, and 4. Okay. And subtree size, you can see for the it is 7. For the second node, it is 3. For the sixth node, it is 1, then 5, 1, then 1 for the 1, it would be 3, then 1 and 1. So this is what I have computed using DFS. So let's see how I am computing the answer. So I will apply DP, means suppose if I have just chosen that I am going to leave this node, I am going to leave this node. Leaving this node means I am not going to add its value to my score. Means this will not contribute to my score. Okay. So if I am leaving this node, so all the, obviously suppose if there is a node and there are some other nodes, and if I just choose these nodes, obviously all these leaf nodes, all the leaf nodes will be having value greater than 0, because even if I just choose every other nodes lying on the subtree of this node which I have just left, so obviously all the paths from the this node to the leaf node would be having value greater than 0. I hope this is clear. Suppose it is having value 5, and it is having some value, it is having value some value, and I am leaving this node, means I am not setting this its value to 0. Okay, I am not setting this value to 0, so obviously all the paths will be having value greater than 0. So that's what I am telling. So if I just choose this node I, so I will have, I will not be caring about the nodes which lie in this subtree. So I will just ignore, means I just ignore, I will just, what is the subtree size? 7. So, and what is the index? 0. 0 plus 7, I will go to the this index, so I will go here. So you can see that I have traversed all the. So this is one possibility. Suppose if I have not chosen this node, so I will just go for the next index. For the next index, so for the node two, for the node two, suppose if I have just chosen this node two, and what is the subtree size? If I just choose it, if I just choose it, so how many nodes I will have to? If I just choose it, so how many nodes I will have to ignore? How many nodes I will have to ignore? Obviously 3. So I will not take I will not worry about 6 and 5, because I have left this node. I have left this node. So obviously all the paths which goes through 2 will be having greater than 0 value. Okay, so I have no I will not worry about the leaf nodes which lie in this in the subtree of this node. So I hope the concept is clear. Similarly, for each node I will do either take it, not take it. Okay, so if I take it, means I am not leaving these nodes. In that case, so all this I will explain while coding itself, so you will be more clear. So I will first of all create the, so what I will be requiring is that vector int order vector, then sub vector sub denote the subtree size of this node. Okay, and then other is the mark vector, which will be if mark I is 1, then this node is leaf node. Okay, so that's all I need. And yeah, then I will construct the first of all tree. Int n is equals to values dot size. Okay, so let's first build the tree for auto ampersand it ages. So g of it 0 dot pushback it 1, g of it 1 dot pushback it 0. So I have constructed the tree, and then what I will do is that for int I is equals to 1, I less than n, I will mark the nodes which are the leaf nodes. Okay, so if g of I dot size equals to 1, so obviously, and why I have started from I is equals to 1, because obviously it is given that root 0 means 0th node is the root node. So obviously that can't be the leaf node. So if gi dot size equals to 1, means it is only connected to one node, so obviously it is a leaf node. So in that case I will just mark it as mark I is equals to 1, and then I will also keep long sum is equals to 0. What is sum denoting is that sum of the sum of the values of every nodes in the tree. So why I have just to maintain this, because my approach is like that. I will first compute the sum of values of every node in the tree, and I will just subtract those nodes which I am not including in my score. Okay, so my approach is like that. Okay, sum plus equals to it. So this is a total sum, and now int to be removed, I am creating a variable to be removed. To be removed means this will be the sum of, to remove is equals to, this will be the sum of the values of the nodes which I am leaving to ensure that our tree is healthy. Just listen properly. This will be the sum of the values of the nodes which I am leaving for ensuring that my tree is healthy. 0 comma order, or I need to pass order, just pass n, and then values, and other one is, so before that Before doing this, I will have to call DFS 0 minus 1 Z. 0 is the root node, then parent, and then Z, and uh, anything else? No, I don't think so. So this is what. And before that, I also just forgot to resize it. Mark is equals to vector and now let's create the DFS void DFS into V into B vector in G. So if so, I can say that this is the sub of V equals to 1. Okay. So how we calculate the subtree size? This is the way that when I visit a node, I will increment its value to 1, and then I will go to every child. If that is the parent node, then continue. Else, I will do B and G, and then sub of B plus equals to sub of 2. So you should notice one thing, why I am just first calling the DFS and then only doing this, because I this is when we go from first we go from the top to down, and when we are coming back from the back from the bottom to top, then we are doing like, okay, so you have computed the, I will ask, so you have computed the child, for the child I will ask the child, so you have available with you the your subtree size. So okay, you give me your subtree size, and I will just add it to my own subtree size. So this is what been going here. And one thing I forgot here, order dot pushback b. So whenever I just visit the node, I will just push it into the order vector. So I am done with the DFS, and now let's move on towards the to remove. Means the number of this will be the sum of the, this will be the sum of the nodes values which I have left, means which I have not included in my score variable. So solve of 0 comma order vector, no, there is no need to pass because I have created it in. Then only thing 0, and then return sum minus to remove, means this was a total sum, and these are the some of the nodes which I am leaving to ensure that the tree is healthy. Let me write it. Sum of the values of the nodes which I have not included to score to ensure tree is healthy. Okay. So I hope this is clear till now. So long long solve into int I in 10. So if I equals to 1 means I have traversed all the nodes. In that case, it would be 0. Then suppose if this is the leaf node, if this is the leaf node, the node which I am at present, obviously, so the nodes which I am at present would be order of I. So if this is if this is a leaf node, so in that case there is no other possibility. I will have to include it. I will have to include it. So in that case, return values of, sorry, I forgot to pass here values. Values of order of I, because the why I am using order I, because this is the order we have get no. So this is containing the all the nodes values, this is containing all the nodes. So the node which I am at present would be order of I, order of I, and that's all. This is another base case. So I will initialize answer is equal to 1 9 118 plus 7. Now answer is equals to mean of answer. First of all, if I am just leaving these nodes, means if I am just leaving those, and why I am taking minimum, because the node values which I am going to leave for ensuring that the tree is healthy, the sum of those values should be minimum, because I have to subtract, to remove. Obviously if I have just to, I have to subtract. So in order to get the maximum answer, I will have to remove the minimum values, minimum sum. So that's why I am computing minimum. Okay. So first option is I am leaving this node, means not including to my score. Okay, if I am just leaving this, means it will contribute to the sum of the values which need to be removed, so in that case sub of order, sorry, values of order I. So since this need to be removed, so obviously I will have to include it, order I plus solve of I plus, which I have already discussed, that if I am just leaving these nodes to ensure that the tree is healthy, so I do not need to care about the nodes which lie in the subtree of these nodes. So I will just jump to the other nodes which doesn't lie in the subtree of this node. So for doing that, this is the, because I have I plus then size of this subtree. Okay, I hope this is clear. And suppose if I am including this to my score, then in that case, answer comma solve of I plus 1 comma values. I am including this to my score. Finally, I will return answer. So obviously this would not pass because I have not memorized it. Let's just memorize it. Long dp, then dp is equal to vector long n comma minus 1. If dp of I is not equal to minus 1, in that case return dpi, and dpi is equal to answer. So let's run it. So compiler error 0 n. Okay, I have not passed the values here. Sorry, there is mistake somewhere. So values sum id. Okay, let's see from the starting itself. So DFS sub of V is 1, order dot pushback, then 2 is equals to P, then sub of V plus equals to sub of 2. It is fine. Then long solve int I, Then mark, if mark order I, so return values order I, values order I. Then, oh sorry, if this is the node, this might happen that this is not the last node of the tree. Okay, although it is a leaf node, so obviously other nodes can also exist. So in this case I will have to write sum of dpi is equals to solve of I plus 1, because 1 is the size of the leaf node, so that's why I am incrementing it by only 1. Then order, sorry, values. I hope this should pass. Yeah, it is giving right answer now. Let's submit it. So yeah, it got accepted. So that's all about the solution. I will suggest, just first of all, try run over the examples which I have explained, the way I have explained. Thank you.